Students, today we will solve one important problem in Green's theorem, that is, so verify Green's theorem by evaluating line integral along the curve C x cube minus xy cube dx plus y cube minus 2x by dy, where C is the square. So here we have a curve that is a square having vertices at the points 0 0 2 0 2 2 and 0 2. Now coming to the graph, we have 4 points. First one is 0 0, so O. Now second one is 2 comma 0, and the third one is 2 comma 2, and the fourth one is 0 comma 2. So we have the direction which is anti-clockwise direction, so the direction will be like this. So this is C1, C2, C3 and C4. We have 4 curves represents the closed curve, which is a square, to be evaluated. Now come to the solution. So by Green's theorem, so what is the formula in Green's theorem? That is the line integral along the curve pdx plus qdy equal to double integral over the region dou q by dou x minus dou p by dou y into dA. Okay students, now coming to the what is given, that is the line integral along the curve x cube minus xy cube into dx plus y cube minus 2xy into dy. Now we have to evaluate this by using all these 4 curves. The first one is along C1. So along C1, what are the boundaries? What are the variations we have to observe is from 0 0 to 2 comma 0. So clearly, so x is ranges from 0 to 2 and y is ranges from 0 to 0. So the no change in y, which means y equal to 0, since dy also equals to 0. So directly we can take dy 0. Why? Because no change in y, so rate of change in y is equal to 0. So finally, or else we can differentiate y. So what we get dy, we can differentiate 0, what we get 0. Clearly we have the boundaries which is from 0 to 2. Then coming to the line integral, so from 0 to 2, so what is y? 0, so that x cube minus 0 into dx plus, clearly we have y which is 0, so now substitute 0 here, 0 minus 0 into 0, which is 0, so clearly it is 0. Now finally what we get? X cube, the derivative integration of x cube is what? X power 4 by 4. The boundaries are 0 to 2. Now substitute the boundaries, 16 by 4, which is equal to 4. Now along C2, so along C2, so what are the changes we observe from 2 comma 0 to 2 2. So clearly it is 2 comma 0 to 2 comma 2. So that, so finally what we observe, so the no change in x. Why? Because x is ranges from 2 to 2, which gives completely x equal to 2. No change in x. If no change in x, what is the rate of change in x? Is equal to 0. Or else derivative of x dx and derivative of constant is equal to 0. So it is a value, and y is ranges from 0 to 2. Okay, now coming to the line integral, so integration of 0 to 2, so dx is what? 0. So since the entire value is equal to 0, so this one is 0, and so what we have? X equal to 2, so that replace x with 2 here, then what we get? Y cube minus x is 2, so that minus 4y into dy. So that we need to integrate y cube minus 4y, so with respect to y, so that for y cube it is, so what is the integration for y cube? Simply it is y power 4 by 4 minus, so for 4y, so it is 4 into y square by 2, and the boundaries are from 0 to 2 clearly. Now substitute the boundaries. 2 ones are 2 twos are, so 16 by 4, so 2 power 4 is 16, 16 by 4 minus 2 into 2 square, which is nothing but 4. Coming to the lower boundary, it is 0, no need to substitute, so 4 ones are 4 fours are 4 minus 8, which is equal to minus 4. Now along C3, so along C3, so what is the variations we have to observe is 2 2 2 0 2. So clearly 2 comma 2 2 0 comma 2, these are the changes we observe. So since x ranges from 2 to 0, clearly x is ranges from 2 to 0 and y is ranges from 2 to 2. Since no change in y, which is y equal to 2, no change in y, then if no change in y, then the derivative should be equal to 0. So here the change is for x, so that coming to the line integral, which is from 2 to 0, and y is what, 2, dy is what, 0, then from this y is 2 and dy is 0, so that entire value is equal to 0. Now here from this we have x cube minus x into y is what, 2, x cube minus x into 2 cube, clearly it is x cube minus x into 2 cube into dx. So all the time please observe the boundaries 2 comma 0, since that direction of the boundaries is different. So since what we have 0 to 2, but here we have 2 to 0, so that we have to interchange the boundaries. Why? Because lower boundary always having the least value and upper boundary always having the highest value, but here is a different one. So lower boundary is 2 and upper boundary is 0, so that we need to interchange the boundaries. So clearly x cube minus 8x into dx. Now coming to the integration for x cube, it is x power 4 by 4 minus 8. For x we have x square by 2 and the boundaries are from 0 to 2. Now minus of, now substitute the boundaries. 2 power 4 is what, 16 by 4 minus 2 ones are 2 fours are gets cancelled, 4 into 2 square is what, 4, 4 ones are 4 fours are, so minus of 4 minus 16, so 4 minus 16 minus 12, since it is 12. Now along C4, so along C4 it is from 0 to 2 to 0 to 0. So clearly no change in x, so here x is ranges from 0 to 0 and y is ranges from 2 to 0. So no change in x, since dx equal to 0. Why? Because the derivative of x dx and it is 0. There is a change in y coordinates, which is 2 to 0. So clearly the line integral from 2 to 0 and x is 0, sorry, dx is 0, x is 0, so that if dx is 0, x is 0, what we get, so complete value equal to 0. Why? Because dx is 0, so no need to take this, and x is 0, so that this one is 0, so that what we get finally, y cube into dy. Why? Because this one also equal to 0. So why? Because here dx is 0, x is 0, so this one is eliminated, here x is 0, this one is eliminated, finally what we get, y cube dy. So y cube dy. Now coming to the boundaries, so clearly it is from minus 0 to 2, so we have to interchange the boundaries. So why? Because least boundary is 2, upper boundary is 0, so that we need to interchange. So y cube into dy. Now for y cube it is y power 4 by 4, the boundaries are from 0 to 2. Now substitute the boundaries. Upper boundary 16 by 4, 4 gets cancelled, since it is minus 4. Now while adding all these terms, finally what we get from this, so this is the line integral we need to integrate. So line integral of x cube minus xy cube into dx plus y cube minus 2xy into dy equal to, so all four, the first one is 4, the second one is minus 4, the third one is 12, and the fourth one is minus 4. So along C4 it is minus 4. Now coming to the simplification, so 4 gets cancelled, 12 minus 4 is equal to 8. Now coming to the Green's theorem, so what it is, so double integral over the region or, so dou q by dou x minus dou p by dou y into dA. So clearly, so from this problem, what is p? X cube minus xy cube. What is q? Y cube minus 2xy. Now first one is dou p by dou y. So if you want to differentiate with respect to y, since it is a partial differentiation, so if you want to differentiate with respect to y, treat x as a constant, so that the derivative of x cube is 0. Treat x is a constant, minus x is a constant, put it outside. For y cube it is 3y square, so that minus 3x y square. Now for dou q by dou x, so clearly for y cube it is 0. Why? Because we need to differentiate with respect to x, since treat y as a constant, minus 2y into, for x it is 1, so that the final value is minus 2y. Now coming to the, so double integral over the region or, since what are the y boundaries and what are the x boundaries, so y boundaries from 0 to 2 and x boundaries are from 0 to 2, no change. So that, so x boundaries are from 0 to 2 and the y boundaries are also from 0 to 2. Now substitute the formula, dou q by dou x. Dou q by dou x is what? Minus 2y. So minus of dou p by dou y, it is plus 3x y square. Why? Because minus of minus into, so we need to integrate with respect to y first, so that dy into dx. Now, so from 0 to 2, so minus 2 into, for y it is y square by 2 plus 3x, for y square it is y cube by 3. From 0 to 2, so 3 gets cancelled, 2 gets cancelled. Now substitute the boundaries, so 2dx, substitute the boundaries here. What we get for y square, 2 square is what? 4 minus 4 plus x into, we need to substitute in place of y only, so 2 cube, it is 8x into dx. We need to substitute in place of y only. Why? Because it's the first integral in terms of with respect to y. Now coming to the second iteration with respect to x, so it is minus 4x plus, for x it is 8x square by 2. So for minus 4 is a constant, for 1 it is x plus 8 into, for x it is x square by 2, cancel out. Coming to the boundaries, it is 0 to 2. Now substitute the boundaries, minus 4 into 2 plus 4 into 2 square, so minus 8 plus 4 into 4, it is 16, clearly it is 8. Coming to the line integral, what we get? 8. Coming to the Green's theorem, what we get? 8. Since LHS equal to RHS, so Green's theorem is verified. Okay students, thank you.